Hi all, today we'll be talking about high availability for OVN DBs along with the scale test. Basically, we wanted to know that what components, obviously when we use scale, different components for OV and OVS combined can be improvised. There are already talks in upstream and work in progress for some of the components, including the OVN controller processing that Han mentioned. And there is already some performance gain for some of the components called OVS vSwitch T. So the idea is, why do you want to have scale test? So we wanted to simulate the case where in a big cloud deployment like eBay, if you want to simulate an entire availability zone, you want to make sure that OVN can handle that load, make sure it's behaving correctly, and also, of course, bugs, to make sure we get bugs as early as possible identified and fixed. So the question was what to use for scale test. So pretty much we are one of the biggest OpenStack deployment. So there was an open source project OVN scale test that was open source like last year for as a benchmark, as a plugin for OpenStack Rally. So basically we didn't knew as a part of scale, we want to know that what is failing, what is causing the failures. So pretty much we went live and adopted Rally. So Rally is a pretty much nice, convenient benchmarking tool. It gives you a nice report of what were the failures, what was the success. The upstream repo for the OVN scale test is in OVN scale test under GitHub. Feel free to try it out. Now, for scale test, you basically don't need an entire OpenStack deployment. You just need Rally install. And then on top of that, you follow the installation steps. But before we dive into the scale test, there are a few of these keywords you may need to get familiar with. So one is the deployment, which is the base thing that if you want to scale test, you need to have your deployment ready, like how many computes you want to test against, how many logical routers, how many logical switches. And basically, Rally has a task. So each of the CRUD operations on any of the computes or switches or routers is a task. And farm is nothing but a collection of sandboxes, which is basically OVS sandboxes that act as a chases. Now, before we dive in to the scale, we wanted to know that, okay, let's set a base benchmark that we always use these numbers for an availability zone as a part of OVN. So we decided to go with 8 routers because, say, in a live environment, we have 8 gateways plugged into the uplink switches. So we want to make sure that, okay, each router is residing on one of the external gateways, and 5 switches per routers, 250 logical ports per switches, which is fairly a /24, and a total of 10,000 logical ports, which is 10,000 VMs in an availability zone. And for testing, we basically stick to one operating system version, mostly Ubuntu 16.04 with 4.4 kernel. Now, before, again, just want to brush up on the OVS DB service models. We have 3 service models here as a part of OVN setup. Either it's standalone, active backup, and cluster DB using raft. So each of them have their own set of implementations and limits. I just want to give the architecture diagram of how we can have an active standby setup works in an HA, and if we are managing it through pacemaker. So now we also have a load balancer support for starting the pacemaker scripts, including the OVN kettle, so that you can, in an active standby setup, there is only one node which is active, which has all 3 components running, northbound, southbound, and north D. And all 3 components, all 3 nodes you can place behind the whip, so that the cloud management system can talk to the northbound through the whip, and the chases can talk to the southbound databases through whip. I'm not going to the details of how to start the services and stuff, but just a snapshot. You can also let the whip resource managed by pacemaker, so that the only limitation is, if you, just going back here, see if you put all the 3 nodes under the same fault domain, top of the rack switch, then you can also let pacemaker manage the whip resource. But ideally, we don't, in a real environment, you don't want to put all the 3 nodes under the same switch. You want to distribute. For the load balancer to work, you need to set listen on master IP to no, so that active node will listen on 0.0.0, basically accepting the connection to the load balancer, and load balancer will route the traffic to only one active node at the same time. Second is raft. Raft is all HA, which is all active-active. So all 3 nodes can act as an active node, but the raft is implemented nicely that at one time North-D will use name lock so that only one of the North-D is responding, converting all the northbound databases data to the logical flows into southbound to avoid any race conditions. Now for raft, again, the same thing. You might need to, you can either provide a comma-separated 3 nodes setup for the chases to talk to, or you can use the web. It's preferable to use web because if one of the controller node dies, you don't want to update all the chases OVN DB settings to point it to the new remote. Now for the scale test environment, how to set it up, that's a base thing. So how we decided is we have a testing rack. We had like bunch of, we decided with the numbering. So as per the base benchmarking numbers that I suggested, we decided to use 20 farms, which acts as a bare metal. And one is our scale test node, which is Raleigh node. Obviously, it will be installing OVS, OVN on all the farm nodes, including setting up of the central node. So you need to have authorized keys and SSH, the prereqs to be set up. So basically, scale test boils down to 3 commands. First is create the deployment, run the task to start the chases, and third is to actually create port and bind the ports to the chases so that it's pretty much similar to simulating your virtual machine environment. So in the this is just a simple payload. You can specify the repo. You can give the branch, which customized branch we need to test to. And this is the payload for just one farm and one central node. So as a part of deployment, it sets up one standalone OVN central node, which has northbound, southbound, and North-D installed. Next is to set up the chases. So on this farm, since we are planning to use 10,000 logical ports, we use 50 chases per farm node. So basically, we'll start 50 sandboxes on all of the farm nodes. And all these sandbox, once you start the chases, they'll start connecting to the central node. And you can always, when the task is running, you can always do sbctl commands to monitor the count on if the count is increasing. So basically, you specify the amount of farm nodes needed, amount of sandboxes you need, and you also add a tag basically for all these 50 chases here. You'll see they are under the same TOR, which is a farm. So you also have a tag there. And you provide the controller, like which controller central node they need to connect to. Now for routers and bind ports, again, the payload is pretty simple. You don't specify which farm, which chases it should connect to. You directly give the amount, like, okay, you need this many routers, you need this many networks, and this many ports. Of course, there are some arguments, wait up, wait sync, whatever. Depending on the use cases, you can run the cases. So wait up is basically you wait for a VM to come up in a live cloud environment. So you want to simulate that. So this is what happens when the task is going on. You'll see the ports are coming up on the hypervisors one by one. And if you'll, as per the 10K logic, this farm will have like 500 ports. So we have 20 such farms. So it will complete the 10K count, which I'll show it in the demo if time permits. So this is how a scale test report looks like. So I was not able to import the HTML here, so just dump the snapshot. So if you'll see the test for 8 logical routers, 10,000 logical ports, and 1,000 chases took 13,815 seconds, which is roughly 3 hours and 8 minutes. You'll see the success rate, that how many were success, how many are failure here. It was a successful test run. So you can see it's fully completed and everything was passed. You'll see here, first of all, I'm taking the output of, so each task you can generate the HTML output or JSON output, whatever you want. in the desired format, but this is the task result for the routers. You can also take the task result for the sandbox, because sandbox again is a task. So here you'll see first we create routers. Each of this is the code base in the OVN scale test. You'll see create routers, create networks, create logical switches, create logical ports, and you start binding the port and wait up. So eventually if you'll see, the time is increasing for the bind port as the scale increases. I just trimmed down from 0 to 40. So if you'll see, there are 40 batches. One is each logical port, we create 250 in one shot. So 250 cross 40 completes the 10K count. So just want to give the highlight of how a sample report looks like. Now with HA, so this by default scale test, what it does is it sets up it installs one controller in a standalone mode. So it doesn't by default installs an HA setup. So for HA, what we do is it's still manual. You either use 3 virtual machines, or since we have set 3 controller nodes as a benchmark, you set up manually on your own and make sure you either update the controller CIDR to use this VIP IP, which you are passing in as a part of deployment, so that when you start the chases, ideally it's advisable that when you start the task for starting the sandboxes, you have the HA deployed, so that when sandbox will start, it will directly connect to this IP and the respective ports, so your setup will work. It's again to do, like we are still figuring out that if we want to add this support in the OVN scale test, so that we can also by default set up 3 sandboxes for central nodes as well in HA. So that is how we'll test the HA. So after all is done, the main agenda here once again was we wanted to simulate the control plane impact, including the data plane impact, for when you're running on scale. Say what happens that you already are running with the central nodes with 1K chases. Now what happens when you reboot the active node, and what are the consequences? So I've just listed it out in the tables. Say if you are rebooting anytime any of the standby nodes, there'll be no impact, obviously. Say if one of the active node is rebooted in case of pacemaker. So for active standby, we are pretty much using pacemaker to manage the environment. So say if you'll reboot the active node, pacemaker will promote one of the standby node as a master node, and there will be a little bit of control plane outage, because what happens is it restarts OVSDB, and it has to make sure the active node listens, in case of load balancer, listens on 0.0.0. So when the new master comes up, it tries to sync. So southbound DB pretty much runs super hot, because all of a sudden when the new node is promoted, all the 1,000 chases try to connect to southbound database. And there's like 5+ minutes of approximate blip, you can say, that there's an impact where it kind of freezes. You'll see the southbound is running super hot, southbound OVSDB server. Data plane impact, existing data plane, there is no impact, say, for the existing 10,000 chases. But say if you are binding 1 extra chases during this failover, you'll see that there is a hit for this 5 minutes for this newly created provision binded logical port, or say a provision VM in case of a cloud environment. So if you'll go and log into the chases and check the OVS flows in the OVN controller, you will not be able to find the appropriate flows, because southbound is so hot that it's the entire details about the port for the open flow rules is not yet populated all the way down to the chases. Now again, if all of the active and standby nodes are rebooted, obviously it's a control plane impact, because whichever node comes up first, and it again tries to resync and comes up as an active node, so it will take few minutes. Data plane impact, there is no. Ideally, it should be no, but there was one corner case where during testing, we found that you reboot all 3 nodes at the same time. So pacemaker, there was some race condition where the entire northbound database got flushed out. So basically, whatever 1,000 chases and logical ports you had created, everything got lost. So chases, obviously, it will reconnect because it's okay, but all the ports and router details got flushed out. So we raised this issue with community, and the issue was fixed. Thanks to the community for this again. And we ran the test, and we ran this whole reboot scenario again, and we saw no more issues. So that was one of the good fix. So because you see all of your VMs are gone from the northbound. So that was a disaster scenario. So for active backup with pacemaker, there's obviously, we are going with the basic functionalities tested. There's always more improvements to go. As you saw, the window of few minutes when there's a failover, we are still working with community to see how we can improvise the same. And obviously, there will be more improvements coming up. Now for raft. Raft, everything is HA. There is no standby here. So obviously, when you'll reboot any of the active node in a 3-node setup, there will be no impact. But in case of all of them getting rebooted, there'll be few minutes again, but there is always some talk like, say out of the 3 nodes, if one node is dead, and in raft you always need to have odd numbering of nodes for leadership and stuff, election. So there are whole sort of different things going on there as well. For impact on data plane, I honestly did not get a chance to fully verify it. So didn't want to say yes or no directly. Raft will scale test. Yes, so raft will scale test, there are a bunch of issues going on right now when we use OVN scale test. We are seeing that if you are creating like 2,000 plus logical ports, if those are like when you reach the limit of 2,000, 3,000 logical ports, you are seeing DB timeout issues with the northbound when you are running the scale test. So obviously, this is already proposed and submitted at upstream about the issue. Also, upstream came up with a raft torture test, which you can run on your local laptop when you're running make sandbox, which is also just to give you the idea. But yeah, there are some fixes for raft which are recently uploaded in upstream. We are going to try it out with the scale test again to see if that has fixed and the test completes. There are some of the tunings which we wanted to share as a part of what we noticed, that all of a sudden when 1,000 chases try to connect to the central node, you'll see so many, say one of the example where you will see TCP sync flood messages in the syslog. So you definitely need to tweak that. Some of the tunings for pacemakers also need to be handled. Also, one of the other thing is, if you are using pacemaker, you need to disable the upstart, because when you reboot the node comes up back as a standalone. And if you are using load balancer, it gets confused because it tries to read the local connection table and it tries to open the connection to the load balancer VIP IP. So load balancer can actually send the traffic to backup node. And since the backup database is already in the read-only mode, you will be having a control plane impact. So these are some basic things we wanted to share. This was one of the promising outcomes that we fixed with help of upstream. So when you are running at scale, OVS vSwitch on the chases was running like super hot. So when you are trying to bind the port and doing wait port up, it takes like, it was very slow. So basically the test completed, like if you are running the whole test, it completed in like 8+ hours. So thanks to the community again here, OVS vSwitch was fixed. The discussion can be found out here. So we'll see the orange graph. It's pretty much lenient. As soon as the number of ports increases based on the 1,000 chases, OVS CPU utilization is fairly under control, and the test completes in 3 hours instead of the long duration. These are rough CPU memory stats for all of the components for both central node and chases. I didn't include gateway here because it's more, I wanted to cover the scope here for the control plane itself. So if you'll see like OVN North D do touch is like 0.8 gigabytes on running on scale, just for the sake of, it will vary obviously. I just wanted to give a glimpse of how, what would the stats look like. And yeah, if you are stuck somewhere, obviously reach out to the community whenever you want. Folks are super nice to respond super fast. And thank you. And do I have like 2 minutes to?
Yeah, we have time for questions. So let's thank our speaker before we get started. All right, step up to a mic and ask your question.
Okay. Yep. So, if I guess if I can use 2 minutes to show the environment,
yeah, go for it.
I hope it works. So I think I'll just take a minute to show the environment. So So this is where your recently I just set up with help of Han here for one of the incremental processing patch that he just discussed in the previous talk. So it's just a standalone controller. So you'll see here we have 1,000 chases for the southbound side. $10K logical ports. And now we can pick any on. I want to pick one on this chases for this farm. Sorry. So you'll see if you go in this this box.
It's probably a little difficult to read. You might want to make the font bigger if you can.
Is it visible now? Okay. So in this farm, you'll see there are 50 sandboxes deployed. These are basically your chases. So you go to one of the chases here, say pick one. Let's pick 72.29, I guess. So you need to source because it's a sandbox. So as per the 10K port counts, we bind 10 ports per chases here. So see, logical port here is bounded here. What we'll just do some base checks. In the scale test, we also have the logical flow count. So you can compare the open flow count across all of the chases to ensure that if there is a diff or some chases did not function correctly. So we can also do, so you'll see here there are 45K flows, and we'll grep for this particular, let's pick one port as a reference. It's not showing here. So that's okay, I'll just keep it short. So basically you can also go to, I'll give you the OVS for this particular flow. We are by default using Genève here, since it doesn't really matter whether to use STT as well. And on top of that, you can again go to some different chases on the same hypervisor, on the same sandbox. And say, you can take the flow count to ensure that things are in sync, like close to 45K flows. So basically, this is how you can, there's again one more task you can run to get the flow count to ensure when there's a troubleshooting or failure, you can go and verify on those particular chases what is breaking and what is not. I guess there's too many other things to disclose, but yeah, feel free to hop in offline. I guess I'll be done for that. Thank you, guys.
All right, let's thank our speaker one more time.